You might be wondering what's left to understand about generics. Well, quite a bit actually. I wasn't sure this was the right place to cover these additional topics, honestly, because I don't want to overwhelm you if you're a beginner or discourage you with too much complexity all at once. But since this is a masterclass, I also want to make sure I cover as much as I can in a reasonable way. If you're already feeling a bit confused about generics, maybe save this video for a bit later or review again what I've covered so far. In the next few videos, I want to cover the following topics: using generic references that use type arguments declared in method parameters and local variables, creating generic methods apart from generic classes, using wildcards in the type argument, understanding static methods with generic types, and using multiple upper bounds. I've created a new project called Generics Extra in the dev.lpa package. I'll create a new class called Student, prefixing it with model to put it in the package dev.lpa.model. My student class needs a few fields. I'm interested in a student's name, the course they're taking, and the year they signed up for the course. I'll define name as a string, and course as a string. Year started will be an int. I'm going to spend a little extra time setting up this student class with some extra functionality and complexity. I'll be using this over the next couple of videos, so bear with me for a couple of minutes while I set this up. I want 3 more fields which I'll use to create random data for a set of students. I'll set up a random field to get random numbers. This is protected because I want subclasses to be able to access this helper field. Private static string array called first names, and I'm going to just add 5 different names here: Anne, Bill, Kathy, John and Tim. Private static string array courses, and I'll set that up to have 3 courses: C++, Java and Python. These fields will help me create a lot of students with different data. I've made them static because I don't want each instance to have this data. It can be stored at class level instead. I'm doing this because I will eventually want a larger set of students. Next, I'll create my constructor with no arguments because all the student data will get generated. Int last name index equals random.nextInt, passing 65 and 91. Name equals first names, and the index is random.nextInt, passing 5, plus an empty space and a cast to char of the last name index. Course equals courses, and again the index will be random using random.nextInt with 3. Year started equals random.nextInt, and for this I want to pass 2018 and 2023. I want to randomly generate a single character for the last name. 65 is the integer value for capital letter A. 90 is the integer value for the capital letter Z. So I use 91 in this call because the number generated will be exclusive of this upper bound. I randomly pick an integer from 0 to 5 to get a first name from my names array, then append a space and the last name index to that. I randomly get an integer from 0 to 2 to pick a course from the course list. And the year started is a random integer from 2018 to 2022, again because it's exclusive of the upper bound of 2023. I want to create a toString method for this next. I'll change that code just to return a single line. The returned string is formatted and includes name, course and year started. I want name and course to be left justified, so I use a -15 in both cases in the format specifiers, where negative is the indicator to left justify and 15 is the allotted width. Finally, I'll generate a getter for year started. Okay, this is enough code to give me many unique students, so I'll go back to the main method on the main class and set up a quick test. First, I want a static method that I'll call from the main method that'll print my list of students out. Public static void, print list, and that will take a list of student called students for var student : students. I'm using var here because I might want to change the type later, and I don't want to have to change this here also. I'll print the student out. I'll print out a new line character at the end. This method takes a list of students. Notice I'm not specific about the type of list, so I'm not putting array list there in the method parameter, but just list. Next I want to generate 10 students, so in the main method I'll set up a for loop. Int student count equals 10. List of students equals new array list, diamond operator. I'll loop 10 times. Students.add, and I'll add a new instance of student. Here I start with the number of students I want, so that's 10 for now, and then I set up an array list of student. I assign that to the student's variable, which I've declared as a list of student. Then I loop from 0 to that count and add a new student each time to the list. Let's use our new method. I'll pass students to this method. If I run this now, you can see 10 students whose name, course and year started have been randomly generated. Okay, so that's the setup for a variety of students. I next want to create a subclass of student, which I'll call LPA student. I'll create the LPA student class also in the model package, and I'll have that extend student. I'll add an extra field, which is %complete, that indicates how far along the student is in the course. This will be a double. And I'll type in my constructor, which again will be a no-args constructor. Public LPA student. %complete equals random.next double, and I'll pass 0 and 100.001. This code will execute the super constructor implicitly, and that's going to generate data for the other fields. This class has one additional field, so I want to randomly generate data for it. Here I'm using the random field from the student class, and I get a random number from 0 to 100%. I've added 0.001 there, because I do want 100% to be a valid result, and if I truncate it to 2 decimals, I won't get anything above 99%. Next, I'll generate an override for the toString method, and I'll include this new field in a formatted string. Notice in this formatted string, I have 2% signs after the specify %8.1f. This is how you print out a % sign in the output, so it's a specifier for a % sign. Finally, I'll generate a getter for the %complete field. Now, going back to the main method, I'll copy all of that code except the student count variable and paste it below. I'll change student to LPA student. And I'll change students to LPA students. But I have a problem. You can see the error on that last statement, the call to the static method here. Hovering over that, you can see that the required type is a list of student, and I'm providing an array list of LPA student. Isn't this valid? Well, no, it isn't. This gets pretty confusing, I know. Let's look at this on a slide. We know LPA student inherits from student, and we can pass an instance of LPA student to any method or assign it to any reference type declared with the type of student. We also know that ArrayList implements list, and we can pass an array list to a method or assign it to a reference of the list type, and we saw this in both cases for our student array list. But why can't we pass an array list of LPA student to the method parameter that's declared as a list of student? Surely if an LPA student is a student, a list of LPA student is ultimately a list of student. It's very natural to assume that a method that takes a list with students should accept a list with LPA students, because LPA student is a student after all. But that's not how it works. When used as reference types, a container of one type has no relationship to the same container of another type, even if the contained types do have a relationship. Let's explore this just a little further, because this concept is sure to trip you up. It's important to understand that this restriction has to do with variable reference types and method parameters. First, I'll comment out that last print list call for the moment, and I'll go up to my student array list and add an LPA student to that list after the for statement. That compiles and I'll run it. You can see my last student is printed out with %complete, indicating this student is an LPA student. This confirms we can add any type of student to this list. But consider this next change. I'm going to put LPA student in the diamond operator on the right side of the assignment of our student's variable. And now I've got a very similar error to the one I had with the print list method. Even if I change list to array list in the reference type, I have the same problem. The problem isn't that I'm assigning an array list to a list reference. The problem is the type argument in the references. When we specify student as a type argument to a generic class or container, only student and not one of its subtypes is valid for this container. And although we can add students of any type to the container, we can't pass a list typed as LPA student to a reference variable of list typed with student. I'll revert the last two changes, putting back our list of student to the way it was. Now I'll show you different ways to handle this situation. I'll uncomment that print list statement. You might remember in a previous video with our generic class team, we simply used the raw version of list in the method parameter. Let me show you that first here. That lets our code compile, but IntelliJ is giving us a warning. It says raw use of a parameterized type. But now I can run this code. I get the second list of 10 LPA students, which have percentage complete next to the course. This may seem like a good solution because it worked, but you don't really want to do this, which is why IntelliJ is warning us about it. So what are the other alternatives? In the next video, I'll explore better options, so I'll see you in that video.